Good morning, guys. Those of you who are here, if you go ahead and give me a green check mark, please, and let me know everything's going okay. Thank you, Leeds, and everyone else. Last day we were talking a little bit about the first unit in science. It's the biology unit. We're talking a bit about biomes, why they are where they are. And I gave you guys a climatograph to go through and asked you guys to submit that yesterday. And a few of you did, and most of you did not. So I will be sending out emails shortly to get everybody submitting that. Again, the idea here is that we got to keep moving and get things done. But in order for me to be able to activate you in this course, you have to submit an assignment. And that just happened to be the climatograph, the first assignment. So I need it for two reasons. One, to assess your ability in the course, and two, because I need to activate you in the course to tell the province that you are indeed in my class. So if you have yet to submit your climatograph, it's extremely important that you do so yesterday. Did anybody have any troubles, issues, or questions they wanted to discuss about the climatograph? Like you didn't submit it because you were unsure of this or that or the other thing? Or was it just that you all got really busy shoveling snow on the weekend, were unable to submit it? Well, I don't see anyone typing, so I'm just going to assume that the snow was the reason that you didn't get your climatograph submitted. And I'll stick with that for now till I hear otherwise. I want to continue going through the notes in Unit 1. But before I get there, we do have a few new students, and even those students who have taken part in our program before. I wanted to discuss quickly how to submit an assignment. So if we are in Science 10, this is our main course page. Up at the top under the picture there, I've included a few links to phone apps that you can use to submit an assignment. So whether it be a learning guide, whether it be your climatograph, whether it be your creature assignment from today that we get to, you can submit it in various ways, but the important thing is that it gets submitted as one file. Let's say a learning guide has 30 pages in it. I don't want 30 different files. I need one file. So you can see here, I've included links. Now, the first one, Tiny Scanner for Android, it now costs money. When I first had the link up, it didn't cost anything. The Apple version of Tiny Scanner actually is free still. The one I use is called Cam Scanner. And if you download it to your phone, it's free, doesn't have any viruses or anything associated with it. And basically what it does is it turns your, any pictures you take of your documents, it resizes them to get the proper proportions and gets all the important information. And then it takes all of those images, so 30-page learning guide, it puts them all together in one PDF file, and then you could just submit the one file. So if you have a camera phone, that was the way I would suggest doing it in terms of submitting your assignments. Another way to do it is just take pictures of your pages and put them all in a Word document and then submit the Word document. That works really well also. The only kind of big thing in terms of submitting assignments is that you submit it in one file. So I don't want 500 files or one picture for each page. It's just not very practical for me to open up 30 different pages and then they're the wrong page in the wrong order, or they're upside down or whatever. It's just crazy. So what you need to do is you need to go and either download one of these apps for your phone if you have a camera phone, or if you don't have that, I'm pretty sure those apps will run on an iPad or another device like a tablet. So you take pictures, then you send the email to yourself or just upload it right from your tablet or phone right into Moodle. So if you were to submit the assignment, pardon me, for the climatograph, you would go in here to the assignment, and then yours looks a little bit different because you don't have the grading summary. You will have the submission status down here. It'll say submission status, and you can add a submission just down at the bottom. Click add submission. And when you click on add submission, it asks what file you want to upload. So you can either drag and drop it into this box here, or you can click on the little file with the plus sign, and that'll go into your file picker. So you can choose the file. I know it's a few clicks. And then you just find the file that you want to upload. So let's upload one of Mrs. Ward's assignments, how to spot fake news. Sure, let's pretend that that was our climatograph. So I double click, it loads it in here, and I go upload this file. And then it'll show up here. And then once that file's there, I have to then, after I've uploaded it, I have to save that. And there you go. Your assignment will now be uploaded here. It'll say the date and time it was uploaded. It'll show you the file. And you can always go in and edit it. So let's say you submitted a learning guide and you missed like 5 pages, they didn't upload properly or whatever. You can just go into edit submission, just re-upload the same assignment again. So that is how you are to submit assignments. Again, long as it's one file, I don't really mind if it's a Word document or a PDF or whatever. I'm not too picky. PDF file sizes are generally a bit smaller than if you were to put a bunch of images into a Word document. And I believe the max file size is like 200 megabytes, which is really, really big, but it just saves you time. The other thing is, if you're using a web browser that isn't Chrome or Firefox, like Internet Explorer will not allow you to upload files into Moodle. I'm not sure why that is, but that's just the way it is. So you have to use Firefox. Firefox, Chrome. I think Safari actually works as well, although I'm not much into the Mac thing, so I don't know too much about it. I've never used it or tried it. Chrome, Firefox definitely both work. That is how to submit something in a nutshell. Does anybody have any questions in regards to that? Looks like it's never too late to send it in, Kiara. It is due. You have to submit it anyway, so you might as well just get it done now and submit it. But yeah, it's definitely something you need to get done before the end of, today, hopefully. It was due yesterday. It's not too late. It's not just like, it's over, you get a 0, that's it. No, you can still submit it. It's just, you need to get things submitted on time. That is important. Nobody has any questions about submitting assignments. Nobody had any questions or comments about the climatograph, unless there's some stragglers that just came into class that want to ask a few questions about it. This is your opportunity to ask questions about it. No go? All right. We'll continue on with the notes. So, when I say the notes, what I am referring to, as this is new for all of us, in the Science 10 course in Moodle, when you scroll down to the first unit, biology, it says Unit 1 Learning Guide. Now, for the biology section and the earth science section, we're going to kind of fill in the learning guides together. I'm going to go through some stuff in the PowerPoint behind me, and you will be able to fill in the blanks as you go. And sometimes there'll be a couple of assignments along the way, like the climatograph that you were to hand in yesterday. But the learning guide matches up with the PowerPoints that I'm going through, more or less. So last day we talked a little bit about these 5 key factors here. We didn't discuss this graph, but we will today for sure right now. And as you just as I go through the PowerPoints, you should be able to fill in the notes and answer the questions as you go. This instant practice, is not referencing, well, I guess it kind of is referencing the PowerPoint. Talk a little about latitude and things like that, elevation. So you should be able to fill all of this in as we go through it together. So the learning guides for the biology unit are pretty straightforward. You're just kind of taking notes as I go through it with you, and then we'll have a few assignments along the way. So let's continue on from where we left off last day in the notes. So we were talking about biomes. There's 8 terrestrial biomes. So we're talking about the biomes that are only on land. We're not interested in the oceans. I mean, we should be interested in the oceans, but they're not part of the course. So the 8 biomes are as follows: the boreal forest, desert, grasslands, permanent ice, temperate deciduous forest, temperate rainforest, and tropical rainforest, and tundra. These are the 8 main biomes that we talk about in Science 10. There are other biomes and other divisions depending on where you're learning this stuff. But these are the big ones that we're going to talk about. Then we talked a little bit about why they were located where they are. So what factors? We talked about a few of these. Temperature is a big one, precipitation. Those are probably the big 2. Latitude is where you fall on the globe in comparison to the equator. You have elevation above sea level. And then ocean currents was a tricky one, but that's the one that we often forget about. We never had an opportunity to discuss this chart, and this chart is it's really interesting because it shows all of the biomes. And as I mentioned last class, when we look at a map with all of our biomes, there's really definite lines between the biomes, but in reality it's not as simple as that. If we look at even Kelowna is a really good example. Kelowna is technically part of a boreal forest, but we're really, really close to a desert. So we're kind of almost right in this area. Oh, you can't see my mouse, it's in a different spot. There we go. We're almost in this area here where the grassland meets the desert meets the boreal forest. So it's kind of a funny area where we live. If you go a little bit further south of us, down towards Oliver Osoyoos, you're in a semi-arid desert. It's desert down there in Osoyoos and Oliver. It's very dry, very little rainfall, not a ton of green lush vegetation. You go a couple hours north of Kelowna, you get into kind of like Revelstoke area. It's definitely boreal forest, and they receive a lot of rainfall up there compared to us in Kelowna. So you go a few hours towards the coast, you're going to hit a temperate rainforest, and then if you go a few hours east into Alberta, you're going to hit grasslands. So we're kind of where all of these biomes meet. So this graph is really great because it shows that the biomes kind of overlap a little bit. They're not, you've left one biome, you've entered another. There's kind of overlaps. The main 2 factors that we think about when we discuss where biomes are going to be temperature and precipitation. So you can see average temperature, so minus 20 across the bottom, all the way over to 30 degrees Celsius. So that's probably places on Earth get colder and warmer than that, but the average temperatures would always fall between that minus 20 to 30 degrees. So there's about a 50 degree span where most temperatures on Earth will kind of fall in here. And then if you go up and down the graph, you increase and decrease in rainfall. So down here at the very bottom, this kind of orangey color, this is a desert. Very high temperatures and very little precipitation. You get a little bit more precipitation, you get into the grasslands. And the grasslands is what we like to call a transition biome because it's a transition between a desert and a forest. Not enough rainfall to grow trees, but enough to sustain grass. Then you get a little bit more rainfall and you get into this zone in the middle here. If you're kind of colder, you get the boreal forest. You get a little bit warmer, you get the deciduous forest. And then you get a little bit more rainfall. You get nice warm temperatures, lots of rainfall, you have tropical rainforest. Little colder temperatures, you get a temperate rainforest. And then you have these two on the left, permanent ice and tundra. Permanent ice is very cold. They receive a fair amount of rainfall, and tundra is very cold and doesn't receive much rainfall. So it's a good way to show all 8 biomes, how they kind of overlap, and you'll definitely see that chart again and again and again. Okay, I believe you have these questions in your learning guide, so maybe we can just answer them together. Number 1, the region has an average precipitation of about 175 centimeters and an average temperature of 5 degrees Celsius. So on the chart, we're looking for 175 centimeters of rainfall and 5 degrees Celsius. What do we think? What biome would that fall into? 175 for rainfall, 5 degrees Celsius for temperature. What are we thinking? Jesse has a vote for boreal forest. Does anybody agree or disagree with Jesse and his question, boreal forest? We're gonna second that. Eric, Jenna's gonna agree. All right, I'm thinking that's probably right. So, this is gonna be tricky with my mouse. 175 centimeters of precipitation's right here. So if you go across, and then 5 degrees Celsius looks like it's about here. So that would be this crosshair right here. So you're looking at boreal forest for sure. So well done, Jesse and everyone else. The next question. The region ranges in temperature between 0 and 20, positive, and receives about 100 centimeters of rain per year. So 0 to 20 degrees Celsius, 20 centimeters of rain. What are we thinking? 20 centimeters of rain, 0 to 20. Name that biome. See people typing? Maybe my Blackboard's just really slow, it's not coming up. Is nobody confident in their answers? Grasslands, question mark? Grasslands, question mark? Come on, we spent a whole unit in Math 10 looking at this stuff. Types of graphs. So we had 0 to 20 degrees Celsius. So we're kind of in this range, 0 to 20. And then what was the rainfall? What did we say? 100 centimeters. Was it 100? 0 and 20 and receives about 100 centimeters of rain. So here's rainfall right here. Boom. 100 centimeters of rain on the side. I go across from about 0 to 20. So our rainfall amounts were a little bit low with the grasslands. Ooh, rainfall, you forgot it. Eric's going with temperate deciduous forest. And I would have to agree with Eric. All right, we're getting warmed up here. Let's go to number 3. So number 1, we were talking about what were we talking about? Number 1, 20 centimeter, 175, 5 degrees. We were boreal forest. Number 2 is temperate deciduous. Let's go to number 3. We're good to go. We got this rainfall. We got to check temperature. We got to check rainfall. Has a low average annual precipitation. So it doesn't tell us the exact amount of rainfall, but it says it's low. And a temperature that ranges between -18 and -8. So we're looking at very low precipitation and -18 to -8. What do we think? Low precipitation, -18, -8. We've got a vote for tundra, a vote for boreal forest, another vote for tundra, around tundra. So like inside tundra, outside tundra, or just around the tundra? Jesse's going tundra. All right, I would probably agree with the tundra. If I find -18's just before the 20, -8's just after the 10 here. So this is kind of the temperature range we're talking about. And then it just says low precipitation. So remember, rainfall is being measured up this axis here, the more rainfall. It's just low. You can't get any lower than tundra. There's nothing below it. So if you're in this temperature range, the only two you can possibly have would be tundra or boreal forest. But the low precipitation would lead me to believe it's referring to tundra. All right. We've had 2 warm-up questions, a third additional question. The fourth question is the most important. It's not actually the most important, but I feel like we know how to read the graph good, or well, I should say. The region has an average annual precipitation. Ooh, is this a typo in the question? The region has a high average annual, sorry, I missed the word high. High average annual precipitation, so it has a lot of rain. It's number 4, and an average temperature of 15 degrees. So what I would do is I'd probably locate 15 degrees Celsius and then figure out where it is in terms of the highest amount of precipitation you could have. All right, for all the cookies in the cookie jar, what biome are we talking about? (15 degrees Celsius), high annual precipitation. We've got votes for temperate rainforest and votes for tropical rainforest. I would say those both have high amounts of rainfall, definitely at the top of the graph. What are we thinking in terms of the temperature though? Both. Is it on the line? Is it between the two? Maybe it's a trick question. It's not a trick question. All right, what I'm going to do is I'm going to find 10 degrees. There's a tiny bit in rainforest. Temperate rainforest, we got another vote for. Find 10 degrees here. Here's 20 degrees, so 15 is between the two of them. And then I go up. Boop, beep, boop, 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 beep, boop. I hit the tropical rainforest, and I get even more rainfall. Remember, it said high rainfall. Once I get into the 15 degree Celsius and highest amount of rainfall I can have, but while still being in a biome, I'm in this temperate section. So although you went through the tropical rainforest here, the question said high precipitation. So the precipitation value is read off the side. If I were to look right here, I'm at about 175 centimeters of rainfall, but it said high. So more than 175, I'm up into the 225 here. So I would agree with those who said temperate rainforest. Although we did go through the tropical rainforest to get there, the question specifically said high average annual temperature. Or sorry, high average annual precipitation and then average annual temperature of 15 degrees. So there you go, instant practice. You have instantly practiced. All right, I don't think we spent a lot of time talking about the 5 different factors that establish where the biomes are. So the first one we're going to look at is latitude. We did talk a little bit when I was trying to get you guys to kind of establish where the biomes were and why they were there. We talked a bit about the equator and the Tropic of Cancer and Capricorn. And we kind of discussed that the tropics between the Cancer and Capricorn is where the sun is always going to be directly overhead. So in our summer, the longest day of the year, the sun makes it all the way up to the Tropic of Cancer in terms of being overhead. And then in our winter, the longest day or the shortest day of the year for us in the northern hemisphere, the sun's way down above this line here. So the sun kind of goes back and forth between these 2 lines depending on how the Earth is tilted, either close towards, I should say, or away from the sun. So anywhere in that tropic zone, you're going to get a lot of sun energy, and it's going to be nice and warm. And that kind of establishes things like, if we kind of go back, if we have warm temperatures, we kind of limit our biomes. We have, desert, then we have some desert grasslands, and then the rainforests. As we lower in temperature, we get into these sorts of guys over on the side here. So up at the North Pole, or the northern latitudes, and this is true if you flip it upside down for the southern hemisphere as well, the further you get away from the equator, you get into permanent ice situation. So we talk about Antarctica down here at the very bottom of our map being permanent ice. And then we run into a tundra area. Now in the southern hemisphere we don't have any tundra, but up in the northern hemisphere, this is where the tundra is, at the very northern part of all of the continents across here. And then we go into boreal forest, and then temperate rainforest, and then tropical rainforest as we kind of go down. So that is kind of a generalization of where the biomes end up. And again, this little image with the kind of cutout of the Earth here, if you go into the southern hemisphere, it's just mirrored. How about this? Why is there no, like, we've looked at a few maps of all the biomes, and remember the white in this map represents permanent or polar ice. Why is there polar ice at the very bottom, although it's kind of cut off on your screen? But why is there no polar ice at the top? Why is there no, other than Greenland, why is there no polar ice in the northern hemisphere? Can anyone answer me that? Southern hemisphere, permanent ice or polar ice. Northern hemisphere, other than Greenland, there's no permanent ice up there. Because it's closer to the sun, I wouldn't say it's necessarily closer to the sun, because when we're towards the sun, it's going to be closer, and away, we're going to be further away. So that's not going to work. What's going on up at the North Pole? What's Santa Claus doing up there right now? Why do we not include the polar ice cap on the North Pole in our biomes? We've got Antarctica, we've got the South Pole, but no North Pole. What's going on at the North Pole? What is up there? Is there anything there? Has anyone ever been to the North Pole before? I haven't. It's all ice. It's freezing. Yeah, I would agree with those statements. I think, Connor, you probably aren't the right idea here. What is special about the North Pole? Or what's the difference between the North Pole and the South Pole in terms of the ice that's there? Anthony, I would tend to agree with you. Interesting, though, that sometimes we get kind of desert-like situations on the polar ice. Sometimes they don't get as much snow. I can't believe maybe I've just not asked the question correctly. The North Pole, there's no land there. Yeah, Antarctica and the North Pole are both can be considered deserts based on the amount of precipitation they get. In some areas it's extremely low. But there's no land at the North Pole. The North Pole is just an ice cap. So you hear talk about it now with climate change kind of accelerating, that the northern ice cap will eventually just be gone in the summer. There'll be no ice in the North Pole. I don't know what Santa's going to do. Maybe he's going to have to buy a boat or something. So the North Pole will not have any ice eventually because of the warming of the climate. But the South Pole, Antarctica, is an actual continent. There's actual landmass there, and on top of the landmass is snow and ice. But at the North Pole, it's just ice, and that ice can melt, and it probably will. There's a passageway, the Northwest Passage, that kind of goes from Hudson's Bay area here and up by Baffin Island and across to Alaska. You can drive a boat through here in the summer, and there's actually cruise ships going through here in the summer now because the polar ice is melting so much up north. And if you think about the alternative route, if you want to get from like New York, let's say, to, I don't know, Vancouver on a boat, you would either have to go down through the Panama Canal and then back up all the way over here. But now the summers, it's so warm that you can go up and around. And these islands look skewed. They're not as big as they look on this map because it is normally a sphere, and the tops of the sphere gets kind of spread out when you turn it into a 2D map. But now you can go through the Northwest Passage and then take your boat around here. And it's a lot faster. So you save money on fuel. So your stuff gets there faster. So yes, Northern Pole isn't a landmass, so it's not technically a terrestrial biome, although it is covered in ice. All right, 0 degrees latitude divides the Earth into a north and south hemisphere. And at the equator, the rays of sunshine from almost directly overhead. So you have your tropics in between the Tropic of Cancer and Capricorn. The equator receives about 12 hours of sunlight each day, year-round. And the equator experiences very little fluctuation in temperature. Because that sun's almost always directly overhead, the temperature is very consistent near the equator. That's why you don't get seasons near the equator. So there you go, latitude. Tropic of Cancer is the north of the equator, Tropic of Capricorn is south of the equator. Everything between those two imaginary lines we call the tropical zone. Once we get north and south of those lines, we get into our temperate zones. And the temperate zones, the sun hits at an angle, and because of that, we end up with seasons in the temperate zones. So when our Earth's axis is tilted towards the sun, if we have our sun shining here, the northern hemisphere has summer, and then when we go around, our tilt is away, so we have our sun shining this way now, and we have our winter in the temperate zones. Latitude also affects precipitation. When you're in those tropics, there's lots of sun hitting the oceans, and the oceans get really warm. That warm water evaporates, causing clouds. The clouds get blown onto land, and you get a lot of rainfall. So generally speaking, areas in the tropics, because there's so much energy in the oceans, will receive the largest amount of rainfall. We also talk about mountains and ocean currents affecting this as well. But the big idea here is that all of your tropical rainforests are going to fall between those tropics, because all of the energy that is in the oceans there, because of all of the direct sunlight. All right, the next big one is the elevation above sea level that your biome falls into. So if you are at kind of a low elevation, this little chart here, if you get low elevation, you have a temperate forest. So temperate forests are kind of like leafy forests. This is, if you've ever driven from Vancouver to Kelowna, you definitely encounter all of these different biomes. Maybe not so much tundra and permanent ice, but there are a few glaciers there, I guess. So you have this temperate forest at the low elevation. You go a little bit higher, and you end up in boreal forest. So the difference between these two forests is the temperate forest has kind of leafy trees that lose snow, that fall off in the winter. And then you get a little bit higher, you get into the boreal forest, and that's more of pine trees and things like our neck of the woods. You get a little bit higher, and it's so cold for so long, and there's little oxygen, you get into tundra. So this is areas above 2,000 meters, generally speaking, where the amount of oxygen up there is not quite enough to sustain really large trees. So we call it alpine, above the alpine. You get into tundra, and you get even higher than, into the 5,000 meters. You get into the permanent ice because the snow stays there year round. It's so high up, like you think of a tall mountain like Everest or whatnot. Because the elevation of Everest is so high, it's constantly covered in snow. Even in the tropics, there are mountains like in Kenya, you have Mount Kilimanjaro, and right in the middle of Africa, right in the middle of a desert. But because Kilimanjaro is so high, I forget the altitude of Kilimanjaro, I think it's like 3,000, 4,000 meters. Because it's so high, it's cold up there because the air is so thin, and you get snow at the top of Mount Kilimanjaro. Another example is Hawaii. Has anyone ever been to the Big Island of Hawaii before? I've been to the Oahu a couple times. Jenna's been to the Big Island. Did you ever go up to the observatory? There's a bunch of telescopes at the top of the mountain there in Hawaii. Has anybody ever seen that? No. I've only seen pictures, never been there. I'd like to go there one day. So Hawaii, it's in the middle of the ocean, it's in the middle of the tropics, it's really close to the, well, I guess it's not really close to the equator, a little bit north of the equator, but super warm, rainforest for sure. Then you get up, there's a really big island of Hawaii, and the very highest point of that island, it gets snow in Hawaii. Who would have thought? Just because it's so high, the air's so thin, it's so cold. There you go. So, the more elevation you have, the thinner the air is, the colder it is, and you can get all sorts of weather year-round. I've been hiking down near Whistler before, outside of Pemberton, in the middle of summer, quite literally at the last weekend of July going to August, where it'd be like 30 degrees plus in Kelowna. And I got snowed on just because I was hiking really high up. It's about 2,500 meters. They'll snow year round once you get above certain elevations. Ocean currents are another huge factor. And often people think just because you're next to an ocean means you get a lot of rainfall. And that's not the case, always. So a few examples, the ones that I like to use are, if I go back to our biomes map and we look at the west coast of North America, you can see that up here where we live by Vancouver, I won't get my mouse in the right spot, you end up with a temperate rainforest in here in this area. And you go a little bit further south and you have a desert. So just because you're next to an ocean, in this case the Pacific Ocean, doesn't mean you get a lot of rainfall. All of Baja, Mexico here, most of west coast of Mexico, even up into the United States, this is all desert. It's right next to an ocean. So what makes this area up here receive a ton of rainfall as opposed to this area down here receiving no rainfall? Quite literally, you have a rainforest right next to a desert. Well, we in Vancouver area and then a little bit further inland into Kelowna, we are right next to an ocean current. We get an ocean current. Here's Hawaii over here, by the way. an ocean current coming off the Pacific, which brings warm, moist air. And there's a huge mountain range right here. We have the Coast Mountains. So those mountains trap all that warm, moist air coming off the ocean, and you get a ton of rainfall. Whereas you go a little bit further south, they don't have the same mountain ranges in Mexico and the southern US. These are the kind of Southern California, Texas area here, Arizona. No big mountains to trap that moisture coming off the ocean, not as much of an ocean current, and you end up with a desert. So ocean currents are very important, and there's a couple areas like just off the coast, or not off the coast, on the coast of BC, it was temperate rainforest, New Zealand, and the very southern part of Australia and Tasmania. They receive ocean currents as well there, and they have similar mountain ranges to BC. So New Zealand and British Columbia's west coast are very similar in terms of plants and animals. Climatographs. We talked about these briefly and asked you guys to make one, and you submitted it, or you're going to submit it. So again, climatographs show two things: temperature and precipitation. And the red dots are the temperature, and that's read off the right side of the graph. The blue bars are precipitation, and those are read off the left side. And then along the bottom we have our months of the year from January through to December. So you can see somewhere like Tofino has a pretty consistent temperature, not a huge up and down. They get a ton of rainfall in the winter, and then in the summer, less rain, and then more in the start of the winter again. Whereas you look at somewhere like a Soyuz, and again, these both have the same latitude, 49 degrees north, so 49 degrees away from the equator. Same latitude. A Soyuz, very high temperatures, averaging from, about 0 up to 25 average, but almost no rainfall. So same latitude, you have ocean current coming off the Pacific and a mountain range that kind of traps Tofino on the very west coast of Vancouver Island. And then a little bit inland, you receive almost no rainfall because the mountains have caused the clouds to drop a lot of their rain. So that's an example of why latitude isn't the only factor. You have ocean currents to deal with as well. You guys were doing the practice, hopefully. I believe that's the same chart you guys were given for your climatograph. So January through December, you've got your temperatures from about 5 degrees up to 16 or 17, and then from pretty consistent rainfall from about 120 to up to about 300 millimeters of rain per month. So, adaptations. I believe this is the next section in the notes. We'll talk a little bit about this, and we'll see if we can get to this next assignment. Biomes are often identified with characteristic biotic factors. Remember, biotic means living, so things that live within the biomes. So cactus or cacti live in the desert. What makes them special? Well, they don't need a lot of rainfall to survive, and if you give them too much water, they'll die. Has anyone ever tried to grow a cactus at home? I used to have a cactus when I was a little guy. I gave it too much water, it died. They really don't need any water at all. It's amazing that something can live. You did? Did you do the same thing I did to my cactus, Jesse? It's easy to overwater those things. You just don't know. You lost it. It's not the type of thing you tend to lose, I guess, but if you lost it, you lost it. So they can be hard to keep alive. You were 6. Oh, okay, fair enough. You kill all of your plants. Not everyone has a green thumb. Venus flytrap. Yeah, Venus flytraps are interesting. We'll actually talk about them, Kaylin, when we start doing nutrient cycles, because Venus flytraps are carnivorous. Do you know why they are carnivorous, Kaylin? Do you know why they eat bugs instead of using nutrients from the soil? There's something that they're missing in their diet. So Venus flytraps and all carnivorous plants thrive in areas with very low nitrogen in the soil. So because there's so little nitrogen, they had to find another way to get nitrogen. And the way that they found that was eating bugs. And there's more than just Venus flytraps that are carnivorous. So caribou live in the tundra. They're specifically adapted for that area. Many animals and plants live in specific areas because they have specific adaptations for those areas. So we're going to talk about adaptations. There's three main types of adaptations. You have structural adaptations, and that's a physical feature. You can have physiological adaptations. It's a chemical event. Physiological is probably the hardest to kind of understand, but we'll look at a couple examples. Chemical or physical event inside the body that allows an organism to survive. And then the last type of adaptation we can talk about is behavioral. It's something an organism does. So when we talk about the three adaptations, it's often easiest to think about animals, but plants can have these adaptations as well. So if you're living, you can possess some of these adaptations. So structural adaptation, something like a wolf has very large paws, and those feet are really big to help distribute its weight. So when it's really snowy like it is right now, the wolf can stay on top of the snow, which conserves energy. So that would be a structural adaptation for the wolf. The wolf has many structural adaptations. If we look at him, he's got, or she, not sure which one that is, you got those big ears. That's a structural adaptation that allows them to hear, sharp teeth to eat their prey. That long tail helps with balance. That thick fur allows them to stay warm in the winter. Generally speaking, canines have several layers of fur to keep them warm. A physiological adaptation is that wolves actually produce a chemical in their blood that allows them to stay warm even when it's really, really cold outside. So we're talking like minus 30, 40, wolves are fine. They produce kind of almost like an antifreeze in their own blood. And then a behavioral adaptation of a wolf is wolves hunt in packs. They form groups. That's a behavior. And that pack hunting, they've learned that hunting in a large group allows them to catch more prey, and then the group will be able to stay alive. So those are examples of adaptations. Most organisms possess all of them, but some of them are more obvious than others. All right, so here we have two animals as a porcupine, and I always get my big cats wrong. I think that's a jaguar. Is that a jaguar? Does anybody know what that is? I'm gonna go with jaguar. Yeah. Okay. But is it a leopard though? Could it be a leopard? I don't know what the difference between a jaguar and a leopard is. I probably should. Tough one. Tough one. All right. So we have two animals here. You're second guessing yourself now, Jenna. What type of adaptation? The obvious one is the porcupine. So the back of the porcupine has these really, really sharp quills. What type of adaptation would you consider that? These sharp quills. Would you consider that to be a structural adaptation? It is indeed defensive. Was it structural? Is it physiological? Or is it behavioral? And there's kind of two things going on here. Oh, here we go, leads. Johnny on the spot with the Google. The jaguar is stockier and more muscular than the leopard with a compact body and broader head and powerful jaws. The jaguar's tail is also generally shorter than the leopard. Though jaguars and leopards both have coats that feature rosette patterns, a jaguar's rosettes have spots inside. That's indeed a jaguar then. I'm thinking those black spots have brown spots inside. Thank you, Leeds. You've enlightened us. All right, so Kaylin's saying that this is a structural adaptation that the porcupine has. Would anyone agree or disagree with Kaylin? Nobody agrees or disagrees. You're just going to let Kaylin flounder out in the wild by himself. We got 2 agrees, 3 agrees. Yeah, I would agree with you as well. Has anyone ever seen a porcupine in the wild? Every once in a while when I'm in the bush, I see them. They actually walk around with their quills down. In a zoo, I guess that's another spot you could see a porcupine. So their quills are normally down, and then when they feel threatened, they kind of poke them up, sort of thing. So that would be kind of a behavioral adaptation. They have the structural adaptation, those quills, and normally they're just kind of lay flat, and then they walk around, and if they feel threatened, then they kind of pop them up. So that would be the behavior, moving the quills up, and then the actual structural adaptation would be the quills. So those are some good examples. How about this jaguar here? What sort of adaptations does it have? Just looking at it, not necessarily what it's doing, but just the cat in general. What adaptations does it have? What are some features that makes it unique? And then we can figure out what type of adaptation it is after. I can see probably like at least 5 or 6 adaptations that I could think of on this large cat. All right, let's go with the tail. What does the tail help cats do? And dogs and anything that has a tail, generally speaking, that's kind of long like this. Has anyone ever seen a cheetah run before and seen their tail? It's almost completely still when they're running. The tail doesn't really move around a lot. Does anybody know what that's for? Yeah, Connor, you got it. It's definitely for balance. So what type of adaptation do we think that tail is in terms of this, this jaguar? You've seen an iguana tease a cheetah with its tail. Where do you see this stuff? Is this like a YouTube thing, or you have like a pet iguana and a cheetah at home, Jenna? A really unsafe zoo in Costa Rica. Yeah, I'll tell you my Costa Rica adaptation story here in a second. Leeds, I would, that's very kind of scary, Jenna, but I guess it is what it is. So yeah, structural adaptation, that tail, for sure it's a structural adaptation. If we look at some more, the spots on the side of the jaguar, what do? If you kind of look at this grass that it's standing on, and then you look at it, what are those dots there for? Not like it chose to grow them, but yeah, it's definitely camouflage. So that would be another, structural adaptation. It has camouflaged fur. These sort of dots help break up its silhouette. So if you were trying to, hide from it, or if it's trying to stalk something, it wouldn't be as obvious. Cats generally have really sharp teeth, which are another structural adaptation. Long, sharp teeth, long claws, another structural adaptation. Really powerful legs, and very fast runners, another structural adaptation, helps them run fast. How about this one? This is a snake. Some kind of snake. Has fangs, and out of the fangs, we have venom. So what type of adaptation would we consider venom to be? So there's lots of adaptations here. The fangs are an adaptation, but if we talk about the venom specifically, the jaws unhinge on snakes so they can eat things that are larger than their heads. So poison. Is venom and poison, is that an example of a structural adaptation, a physiological adaptation, or a behavioral adaptation? It has to be one of the three. Structural, physiological, behavioral. I'm going to agree with Leeds on this one for sure. And Kaylin, physiological. So physiological, if you want to think of it almost as a chemical. Anytime you're dealing with a chemical and the kind of human, or not the human, an organism and a chemical, it's generally going to be physiological. So the fangs, those are structural. The unhinging jaw is going to be structural. And you have all sorts of adaptations that snakes have. I don't know if their body would be, probably you could consider their body, no legs, they can fit through spaces that, a bigger animal couldn't. That might be a structural adaptation. Does anyone know what this guy's called? kind of a scary looking dude. This is actually a real picture. This isn't like a fake one. If you've seen Finding Nemo, he's in there. This type of, yeah, this is an anglerfish. Well done, Kaylin. And you know, you hate them? What did they ever do to you, Jenna? They called you a name or something? They are kind of ugly. But they live at the bottom of the ocean, literally kilometers down, in complete darkness. But if you've never seen an anglerfish before, you can look it up. The adaptation that an anglerfish has, don't worry, Kaylin, they're very far down. They have this thing off the top of their head, and they live in the bottom of the ocean where it's completely dark. And at the end of this little, I don't know what we'll call it, protrusion perhaps, this bar, there's this little thing, and it's a light. It actually lights up. And you can imagine if it's completely dark and it has this kind of light happening at the top here, other fish are attracted to that light. Fish are dumb and they like to follow lights. I don't know why, but they do. So anyways, this anglerfish lives at the bottom of the ocean, has this little light above its head, and the other fish see the light and they're like, I wonder what that is. They go over to visit it, and then whammo, your dinner for the anglerfish. So we have a lot of adaptations on this fish. Obviously the teeth quite large, so there's a good structural adaptation. It has a light on its head, which would likely be a physiological adaptation. It's able to create luminescence or light. Notice how small the fins are on this fish. Even the back tail's not very big compared to something like, I don't know, like a shark or something has really, really large fins. Can anyone think of why this animal doesn't really need to have large fins? It has small fins. Yeah, for sure. Connor's, I'm not an expert in anglerfish, but I agree with Jesse and Connor here that it doesn't need to swim very fast because it has this physiological adaptation of this light, and the food just comes to it. So it doesn't really have to go anywhere. Food just kind of shows up and it eats it. Pretty good deal. Has anyone seen the Planet Earth series? These birds of paradise are on it. It's kind of showing up pretty slow. I love these birds. They're hilarious. So this blue and black bird is doing kind of a bit of a dance. And those are actually its feathers. It's not like it's found that. It's kind of fans its feathers out. And it does this little dance. And the blue and black one's the male, and the brown one with the stripes is the female. So this is a mating ritual. Yeah, Planet Earth is the one I've seen them in, at least. There's a bunch of different ones. We'll look at another one here in a second. So what type of adaptation is happening here? There's a couple things happening, obviously, but the little dance, the bobbing up and down. What would we classify the dance as in terms of an adaptation? I would probably go with a behavioral adaptation, kind of like animals like a wolf hunts in a pack. This bird dances, and in order to, secure a mate, it has to have a pretty dance, and if the mate likes the dance, then they go off and create offspring, and that's kind of what organisms want to do, is create offspring. So that is a behavioral adaptation this bird has developed, this fun dance, to try to get this mate. There's this adaptation as well. See, the female sees the male. These pictures are playing really slow. I just came across it. It was really funny when it played fast, but now it's kind of slow and it's not working very well. Anyways, a little parody of these behavioral dance that this bird does. You think about it, humans have all sorts of behavioral things that they do that are kind of absurd, but we don't really think of them in that regard. But if you take the context of the bird and put it into a human sort of situation, it looks kind of funny. This is another bird of paradise. It has these really crazy feathers, and on its neck it has these really shiny patches. So again, it has these really long feathers off the top of its head that kind of hang out off to the sides. So another behavioral adaptation, the dancing, and then these sort of the structural adaptations of the feathers. Has anyone seen these monkeys before or know where they are? Maybe this guy will give you a bit of a clue as to where they are. Has no one seen these before? Last year everybody had seen them. They're like, oh yeah, that's over so-and-so. Yeah, so there's a place in Japan, way up in the mountains, and they have this kind of like a hot spring pool. And they created this hot spring pool for the humans to kind of visit and enjoy the hot springs out in the cool environment. And what happened was the monkeys started living in this pool because it was so cold out. And it's actually quite interesting. There's kind of like a hierarchy between the monkeys. So like the lead monkeys can go in the pool, but the not lead monkeys have to stay outside. And if they try to come in the pool, the lead monkeys get angry, and then only the family of the lead monkey gets to live in the pool. But it's essentially a behavioral adaptation where these monkeys, instead of being cold in the environment, they just swim in this really warm water all the time. So interesting that they've adapted to their environment. Like that. I think we're almost done here. Much of the Earth's biosphere consists of freshwater and oceans. Remember, we're just talking about the terrestrial biomes. There's aquatic biomes. They're essential for life on land. Without oceans, we don't have life on land. The majority of oxygen we breathe actually comes from the oceans and bacteria that create oxygen for us. And the oceans absorb massive amounts of carbon dioxide. And obviously we have rainfall that comes from oceans being nice and warm. So we need the oceans to survive. They're actually a very integral part of the biomes, but we don't talk about them in Science 10. So the oceans are important, but they're not a part of the curriculum here. So as we talk about the terrestrial biomes, you can see maps with 11 or 16 different biomes. And some scientists classify them according to temperature, some classify them according to moisture, and other scientists classify biomes according to the types of plants that grow there. So depending on how you're going to classify them, it depends on how many biomes you're going to come up with. And in Science 10, we usually use the big two, precipitation and temperature, to classify our biomes, and everything kind of fits in with that, and we have eight main biomes. Obviously biomes are complex. They're not just like, this is boreal forest, and boreal forest has these plants and these animals, end of story. No, there's very complex interactions. Different parts of boreal forest will have different organisms depending on where you are. Biotic and abiotic factors, so the living and non-living factors combine, and helps us understand where the biomes are distributed and how changes in a biome may affect the organisms that live there. So there are our biomes. I'm going to tell you my Costa Rica story. I have a few Costa Rica stories, but Jenna, you reminded me of this one. So we talked about animals having structural and behavioral and physiological adaptations depending on where they live. And different animals live in different areas. So we talked about something like a cactus. Cactus lives in the desert. So I obviously live in Kelowna, and in my yard every day I have deer, just because I live kind of right next to the forest. So we have lots of deer in our yard. So everywhere I go around, I spend lots of time in the forest, camping and stuff. We always see deer. So a few years ago, I went to Costa Rica for a few weeks just to kind of travel around. So I'm in Costa Rica. I'm in a rainforest, in like a rainforest, like kind of like a national park almost. And I go for a hike, and I get out of the car in the parking lot. And I turn around, and the first animal I see in this national park nature reserve in Costa Rica is a deer. It's a very small deer, but it's a deer. And I'm thinking, I traveled all the way from Kelowna on like 3 different planes, flew all the way to Costa Rica, and the first animal I see in Costa Rica is a deer. I was so disappointed. I shouldn't say that. It was kind of funny though, because I was just kind of like, I thought I was going crazy because I was expecting to see really cool things like sloths and all sorts of other really amazing animals and monkeys that I'd never seen before. And then there's just deer standing there. So deer live everywhere. They live in the boreal forest, temperate deciduous forest, tropical rainforest. Literally everywhere you go, you will find deer other than kind of like permanent ice. And there's like deer-like animal in the deserts and things like that. So I was disappointed initially, but then I kept walking and I saw more animals in Costa Rica than I could ever imagine seeing in my entire life. It was quite amazing. And Jenna, you've been there, so you probably know. They have those really cool raccoon things that you mentioned that have really kind of long tails. I forget what they're called. I saw sloths and toucans, and I saw a viper, poison dart tree frogs, a couple different types of monkeys. They have these really cool land crabs that are purple and orange, which are pretty amazing. I think I saw like not a capybara. They're not capybaras in Costa Rica, but just amazing, amazing animals in Costa Rica. All right, we have about 20 minutes left. I just want to talk a little bit about the assignment, and then I will let you guys take off for the day. So in the course, hopefully I don't have to log in again. Unit 1 biology, the first assignment here was climatograph assignment due Monday, February 6th. I asked you guys to type it into chat last day, and you did. You said, Monday, Mr. Borden, and then you didn't submit it, which made me sad. And when Mr. Borden gets sad, bad things happen. I created another assignment, create a creature. This one's going to take a little bit more time, create a creature. It's a bit of a longer assignment. You can't just, well, I guess you could do it in like a day sort of thing, but I want to give you guys some time. So it says, please download the following file and complete the assignment. Create a creature, download. You download it, and it looks like this. So I want you to just start thinking about this. It's not due on next class, but we'll make it due next week sometime. We're going to talk about the 8 biomes specifically next day. So as we're going through the biomes, I want you to kind of think about a couple things. We want to think about the adaptations we talked about today, structural, physiological, and behavioral. And we want to think of plants and animals that might have those types of adaptations. So as we go through the 8 biomes, all I want you to do is pick one. Doesn't matter which one you pick. Whatever one's most interesting to you, you're going to pick the biome. Let's say you picked boreal forest because we live in the boreal forest. All right, so we're going through the boreal forest. You think of, some plants or animals that live here. Try to pick plants or animals that are specific to that biome. Something like a deer isn't necessarily specific to any one biome. They're everywhere. So it wouldn't be a good example of an animal that's, really unique to that biome. Something like a pine tree, that's unique to the boreal forest. We have other animals here that don't exist anywhere else. Things like wolves, mainly in the boreal forest. So those would be some sort of animals. So you're going to think of 2 plants, 2 animals that live in the boreal forest, and you're going to describe an adaptation that they have. So let's go with the wolf. So animal number 1, example 1, I'm going to put wolf. And what type of adaptation does a wolf have? So I'm going to go with really sharp teeth. That's a structural adaptation. And I'm going to write structural in the next box. Oh, structural. And then I'm going to describe how the wolf's teeth help it survive. Well, the wolf hunts animals, is carnivorous. Those teeth help rip flesh. That is what the wolf's teeth do. So that is a structural adaptation. I'm going to think of another animal that lives in the boreal forest, and then I'm going to write down an adaptation it has and an example of how that adaptation helps it survive. So I'm going to fill in this little chart. 2 plants, 2 animals. Think of adaptations. If you can't, I'll help you out next day. Again, this doesn't need to be done right away, but I just want you to start thinking about it. The second part of the assignment is this. You are going to think of / create a plant or an animal that has 3 of the adaptations that you listed above. So you're making this up. It's not real. You're going to pick 3 of the 4 here, and then you're going to add an additional 2 to your creature that you're creating. So your additional 2 could be something like it has laser beams for eyes, which allows it to look at its prey and kill it instantly. That would be a good one. It is telepathic, so it can read the mind of its prey and hunt it because it knows what it's going to do next. So you're going to come up with 2 additional adaptations. You're going to label them as being structural, physiological, or behavioral. And you're going to either draw a picture. Now, I am an absolutely terrible artist, so I'm not marking you on your artistic ability. I'm just going to say, yeah, there's a picture there or not. It could, it doesn't have to be beautiful. Or you can write a paragraph if you would prefer to write. You're going to list 5 adaptations, so 3 from the chart, and then 2 adaptations that you're making up. You're going to describe how those adaptations allow that animal to survive in the biome you've chosen. And you're going to give your creature a name. So that is something we'll work on for the next few classes. So we talked about adaptations today. Next day we're going to talk about the 8 biomes, really kind of specific to each biome. And then we're going to take all that information and make a creature and submit this. So if you have yet to submit your climatograph, that needs to be done yesterday. So get that in. If I don't have it by the time I'm done lunch today, I will be sending out angry emails. So get her done. Priority number 1. Priority number 2 is you can start thinking about this assignment, but it won't be due until later next week, probably maybe Wednesday or Thursday next week. Does anybody have any questions before we go for today? Any questions about the climatograph? Any questions about anything else related to the course? Science? See Eric typing. I'll give you a second to finish off your thought. If you do have any questions, you can fire me a private message as well. If you're having issues with Moodle or submitting things or things like that, let me know. But if not, I will assume you understand what's going on and things are okay. I'm going to sign off. Eric, if you are asking a question, I'll answer it just in chat. I hope everyone has a great afternoon, and we'll see you next time. Thanks.